Today, we will talk about IB Math Past Paper, AA Higher Level, Paper 2, Time Zone 1, May 2021. First, we look at question 1. X and Y are two parameters which can be modeled by the regression line. Y equals AX plus B. Part A. Just input the data to calculator, and we can find the values of A and B. Part B. We substitute 18 for X, and then we get 12.3 for Y. Part C. We need to find the mean values of X and Y. Again, calculator work. Part D. We need to draw a line of best fit. Remember, the line must pass through the mean point 15 and 11. Here, I show you an improper example. This line is drawn without ruler, so very ugly and score may be deducted in the real exam. Remember to draw your straight line by a ruler in the real exam. Second question. The mass of a bag of sugar is modeled by a normal distribution with mean 1000 and standard deviation 3.5. It will be rejected if the mass is less than 995 grams. First, we let it to be X. Part A, we need to find the probability of X smaller than 995. By calculator, we get 0.0766. Part B, we need to estimate the number of bags rejected from a random sample of 100 bags. So, we just need to use the answer in Part A times 100, and we get 8. Part C, given that the bag is not rejected, we need to find the probability that it has a mass greater than 1005 grams. So, by the formula of conditional probability, PA given B equals to PA intercepts B over PB. It is just Px greater than 1005 over Px greater than 995. Finally, we get 0.0829. Question 3. A Ferris wheel with diameter 110 meters. The lowest point is 10 meters above the ground. The wheel starts moving with P at the lowest point and completes one revolution in 20 minutes. The height of P above the ground after T minutes is given by a function h. We need to find the unknown A, B, and C. Obviously, h is a periodic cosine function, so A is the amplitude, B is the angular speed, and C is the vertical translation. A is just the diameter of the wheel divided by 2. Be careful, as P moves from the lowest point, but cosine function starts from the highest point. We need to add a negative in front for vertical reflection. To get C, we need to consider the height of the middle point of the wheel. Add 10 to 55, which is 65. B is just 2 pi over the period 20, which is pi over 10. Question 4. We have the velocity function of a particle and a velocity time graph. Part A. We need to find the smallest value of t when the particle is at rest. That means we set velocity to be 0 and solve it. We get 6.74. Part B. We want to find the total distance. Displacement is the integral of velocity, and distance is the integral of absolute velocity. Calculator gives us 37. Part C. Find the acceleration when t equals 7. Acceleration is the derivative of velocity. We put 7 in and get 5.93. Question 5. Consider the expansion of this. And by given that the coefficient of x4 is 20412, we want to find n. First, we write down the general formula of the terms, and then we try to consider the term of x4. So, r needs to be 2. We substitute it back to the coefficient of the general formula above. We get this equation. You may simplify it or not. Finally, calculator tells us that n is 7. Question 6. There are two planes, pi1, pi2, and we want to find another plane, pi3, which is perpendicular to pi1 and pi2 and passes through the origin. For plane equations, we always consider their normal. The normal of a plane is the vector with the coefficients of x, y, and z on the equations. So, normal of pi1 is just 3, 2, and 1, and that of pi2 is just 1, -2, and 1. As pi3 is perpendicular to pi1 and pi2, so does its normal. How can we find a vector perpendicular to another two vectors? Of course, by cross product. Then we get 4, -2, and -8. So, pi3 is 4x minus 2y minus 8c equals to a constant d, as it passes through the origin, so d must be 0. Part B. We need to find the intersection of pi1, pi2, and pi3. Again, calculator. Question 7. A random variable x with a probability density function. When x is between 0 and 4, it equals this, and 0 otherwise. Part A. We need to show this equation. In IB exam, when we see probability density function, 90% of the time, we would like to set the integral of it to be 1. For the integral here, we can use substitution by setting u to be x squared plus k. So, du equals 2x dx. Then, after some calculation and simplification, we get the answer. Part B. Find the value of k. Calculator time again. Question 8. There are two complex numbers, z and w. Part A. We want to find the modulus of zw, and part B, we need to find the argument of zw. That means we need to find zw first. Z actually is in polar form, so we just change it to r/cis theta. However, we cannot change w to its polar form, because the operation between cosine and I sine is not addition, but subtraction. So, what should we do to change it to polar form? As cosine is an even function, we can change the angle inside from positive to negative. And sine is an odd function. We can put the negative sign outside the function into the function. So, we have 8 cis negative 2k pi over 5. After changing z and w to polar form, everything is easy. Product of zw is just multiplying the number in front of cis and add the angles inside cis. So, the modulus of zw is 16 and the argument is pi over 5 minus 2k pi over 5. Part C. Zw is an integer, and we need to find the minimum of k. That means the imaginary part of zw need to be 0. That means the sine part need to be 0, so the angle inside must be the multiple of pi. We change the argument to be a single fraction. Now, the denominator of it is 5. So, 1 minus 2k must be the multiple of 5. As k is a positive integer, the minimum value of k is 3. We just substitute the value we find for k to find the value of zw. We get negative 16. Question 9. B is in 50 meters due east of A. All the information is shown on the diagram. Part A. So that y equals x plus 50 cotangent theta. As there is theta in the formula, we should draw a horizontal line in order to construct a right-angled triangle containing theta. Then, the line here is just the difference of x and y. Now, how can we connect x, y with theta to form an equation? By the trigonometry we learned in middle school, tangent theta equals opposite 50 over adjacent y minus x. Then, change subject and makes 50 over tangent to be 50 cotangent theta. We get the answer. Part B. At time t, B traveled 10 meters more than A. That means y minus x equals 10. B is traveling at double speed of A. That means dy over dt is 2 times dx over dt. Finally, the rate of change of the angle theta is negative 0.1. So, d theta over dt is negative 0.1. Now, we need to find the speed of A at time t. That means we need to find dx over dt. How can we start the question? As the terms we wrote down containing dt in the denominator, and the equation we got in part A connecting x, y, and theta, we should differentiate both sides by small letter t. Then, we get the following. We can substitute the things we find into the equation. However, we find that apart from dx over dt, secant square also exists in the equation, which we want to eliminate. Calculate the value of tangent theta first, and then by the identity secant square equals 1 plus cotangent square, we get secant square equals 26 over 25. Put it back to our equation, and then make dx over dt to be the subject. We get 26 over 5. Section B, question 10. Here is a function f, and we know that f intercepts y equals x at P. Part A. Find the x-coordinate of P. Just substitute x for y into f and solve it by calculator. Part B. Line L has the gradient negative 1, and it is a tangent to f at Q. We need to find the coordinates of Q, so we need to find the derivative of f and set it to be negative 1. Take natural log on both sides, making x to be the subject. We get 2 natural log 45. And then substitute it back to f. We get y equals 2. Here, the question is just testing you the rules of logarithm. Part C. Find the equation of L. As we know, the slope of L is negative 1. By y equals mx plus c, we have the following. And we just need to put point Q into the equation, and we can find C, as well as the equation of L. Part D. We need to find x-coordinate of the point L meets y equals x. So, just set them equal and solve it. Then, we need to find the area of A shown by the graph. Obviously, we need to use definite integral for this kind of questions. We need to check which line is on top and which line is at the bottom. We need to be careful, since there are more than 2 lines here. We cut it in this way. For the left part, orange line y equals x is on top, and L is at the bottom. And x is from the x-coordinate of point A to P. For the right part, red line function f is on top, and L is at the bottom, which is from the x-coordinate of P to Q. Finally, input this complicated thing into our calculator. We get 1.52. After a lot of work, we still have part E. We have a new graph with f and its inverse. The line L is tangent to both of them. Now, we need to find the area enclosed by them. Here, it is not testing us computation, but the knowledge towards inverse function. Inverse function is just the reflection of the original function by y equals x. So, the areas of these two parts are the same, and the colored part is just the answer we find in part D. So, the final answer is just a double, 3.04. Question 11. Function f is this, and x cannot be p and q. Part A. We need to find p and q. For a rational function, its denominator can never be 0. So, we just set it to be 0 for finding p and q. Solving simple quadratic equation, we say p is half and q is negative half. Part B. Find f dot x. Using quotient rule, done. Then, it tells us that y equals fx has exactly one point of inflection. For part C, we need to find its x-coordinate. So, we can differentiate once again and set it to be 0. Or, in the real exam, just ask your calculator. Finally, we get x equals negative 1.60. Part D. We need to sketch y equals fx from negative 3 to 3. So the values of x and y intercepts, and the coordinates of local maximum and the minimum. Here, I just show you how to use sign diagram and algebraic skills to help drawing the graph. But in the real exam, you just need to be a calculator master. Part E. We have another rational function g, with x cannot be negative 2/3, and we need to find all the asymptotes of g. The vertical asymptote is easy. Just set the denominator 0, which is x equals negative 2/3. As the power of the numerator is greater than that of the denominator, there is no horizontal asymptote, but slant asymptote. We need to use polynomial division to find it. Don't care about the remainder, and the quotient is just the answer. Part F. By considering y equals g minus f, we need to solve f smaller than g. You know what? Paper 2 is the paper for calculator. Question 12. F is a function with the given derivative. Part A. We need to break it into partial fractions. Very easy. We just need to make it back to a single fraction, and by compare their coefficients of the terms, we get b minus a equals 0 and 1 equals ak. So, b equals a equals 1 over k. Part B. Find fx. After we break it into partial fractions, we can easily integrate f dot x to get fx. Just need to remember, integral of 1 over x is natural log absolute x. And by the skill of substitution, we get 1 over k times natural log absolute x over k minus x plus c. Then we have p, the population with initial value 1200. The rate of change is modeled by the following equation. T is the time and k is the upper bound of p. Part C. We need to solve the differential equation to get the following expression for p. Separate the terms with t and the terms with p. Then, we just integrate both sides. As the calculation is complicated, we don't need a calculator, but we need to be patient and careful. After we find the expression of p with a constant term c, just remember the initial value of p is 1200. So, we can put t equals 0 and p equals 1200 into the equation. Finally, we get c. Without careless mistake, we can find the answer for sure. At time t, p is the double of the initial value. Part D. We need to find k. So, very obvious, we need to do substitution. Make p equals 2400 and t equals 10. Put things into calculator. We get k equals 2845. Part E. The final question for this paper. Find t when the rate of change of p is maximum. Be careful, this question is tricky. It is not saying P is maximum, but the derivative of P is maximum. Then you can set the second derivative of P to be 0 and solve it. Of course, use your calculator. Anyway, here I just use the computing square for solving this question. After computing the square, I know P derivative would be maximum when P equals K over 2. So, we just use the value to find dP over dt and the value of t as well. We have gone through all the questions in this paper already. Thank you for watching. If you like it or want to know more, please like and subscribe my channel. Bye bye.